name is Sam Webb, and this is a STEM revision session for A-level physics. We're going to be doing specific charge first, and I'm with St.Ivo's A-level physicist.
Hi Sam, it's a privilege to be here.
Can you say in the first show?
So, what is specific charge?
Well, the specific charge is the charge in the amount of 1 kilogram of that particle. And so, if we had 1 kilogram of protons, we'd have 9.5 times 10 to the 7 kilograms, coulombs in that particle.
How do you find that number?
And so, the way we find that number is we have to do a simple equation, which is we're drawing a triangle. Charge on the top denoted by Q, mass on the bottom, and specific charge on the bottom left. And so, if we do charge divided by mass, we get specific charge. Simply this divided by this is specific charge.
Right, well, these are pretty long numbers, Sam. I don't know how I'm going to remember these.
I don't know how you remember either, and that is why in the exam you'll have a formula sheet, and you should have at least 2 of these variables, okay? And so, on top of that, you should have yourself a graphical calculator.
Cheers, Sam.
I've got my one too, just in case. And so, if you wanted to find out the specific charge of a neutron, we'd have to do 0 divided by the mass of a neutron. Know what that is?
That'd just be 0.
That'd be 0. And the same for an electron, goes for this number divided by this number to get this number. Charge divided by mass equals specific charge. Equally, we could do charge times mass equals, specific charge times mass equals charge, or charge divided by specific charge equals mass. So, we'll start with a question. A copper-63 atom loses 2 electrons. For the iron-formed, calculate its charge in coulombs. And so, how are we going to do that, Tom?
Well, we know that if it's losing 2 electrons, then it's going to be a +2 ion.
Exactly. And so, if we want it in coulombs, we'll have to do the minus, because it loses 2, and the charge of an electron in coulombs, which is 1.602 times 10 to the minus 19 coulombs. And we'll have to times that number by 2, and that will give us...
That will give us 3.204 times 10 to the minus 19.
And what's the unit?
Coulombs.
And so that will be the amount of coulombs in this atom of copper-63. Now, for the next question, how many nucleons is in copper-63? Copper-63 has 29 protons and 34 neutrons, and so 29 plus 34 is 63, and the answer is that it has 63 nucleons, because a nucleon is a proton or a neutron. The last question, we need to calculate the specific charge of this ion, and so all we're going to do is, first of all, find the mass, find the charge, and divide charge by mass to get specific charge. And so, first of all, we're going to do 29, the amount of protons it has, times by the mass of 1 proton, 672 times 10 to the minus 27 kilograms. And what that equals on?
4.8488 times 10 to the minus 26.
Kilograms. And then we're going to do the mass of a neutron, times by 34. The mass of a neutron is slightly higher than a proton. Doesn't make much of a difference, but it's good to include it anyway. 7 equals
5.691 times 10 to the minus 26.
times 10 to the minus 26. We can add those numbers together to get the mass of the nucleus.
1.05404 times 10 to the minus 25.
You should always write all the decimal places out, and with the answer, write as 3's and figures. And we can add on the mass of the electrons as well. I mean, you don't have to, but it does say ion and not nucleus, and so it's a very small mass, but we should have to do 29 minus 2, because it loses 2 electrons. We know that there are 27 electrons, and we have to times that by the mass of an electron, which is, if you look at the formula sheet, 9.189 times 10 to the minus 31.
2.459 times 10 to the minus 29.
Well, that stays to the minus 29, that's more or less it. And we can add that on to this mass here to get the total mass.
1.054 times 10 to the minus 25.
That's our mass. And we know from the equation that charge divided by mass equals specific charge. And we know from question 1 that the charge of the ion is actually 3.402 times 10 to the minus 19 coulombs. We do that number up here divided by the mass to get a final answer, which is
we get 3.039 times 10 to the power of 6.
3.0, so that's a
3 million.
good 300,000, is it?
3 million.
3 million? Oh yeah, the 3 million coulombs per kilogram minus 1, a specific charge. And that's how you do specific charge.
That's it.
Thanks for watching.
Sound mate. That's really helpful.